Alright, today we're going to do different real-life examples of free body diagrams and explain the different forces and what they all mean and the net force.
So for this following video, just assume that all of our free body diagrams are going to be based on an XY coordinate system, where this is the Y positive axis and this is the X positive axis. And then all of our objects are going to be represented with a dot, and then the following forces will be labeled. Our first example is going to be an example of a free body diagram where an F net equals 0.
So since Morgan is standing still, she's not moving, her and the floor are an action-reaction pair. And if you have a person just standing here, come on, buddy. The forces are right here, so you have her weight pushing down on the floor and the weight or the floor pushing just as much normal force back into her. And F net is equal to 0. Okay, for our second example, we're going to show a real life example of a free body diagram where F net is not equal to 0.
So in this scenario where I am being pulled in a direction, we're assuming that the F net is going to be a non-zero. If in this scenario I was moving with a constant velocity, it would be true that the F net is 0. But because I was being pulled from a stop, we're assuming that my body is accelerating, which means we do have a value for F net.
Okay, so what just happened was Morgan was pulled by Jess. So if you're thinking about Morgan's free body diagram, she's having a tension force right here. She's being pulled to the side. She still has the same normal force, still has the same weight, and since we're ignoring friction, the F net is going this way.
Alright, for our third example, we're going to do an example with kinetic friction and Alright, so just for clarification, I was being accelerated while being pulled across the table. I was not moving at a constant speed. That's why the F net does not equal 0, and that's why the F net would go to the left. Alright, so for this example, I got pulled across the table as you saw, and there was kinetic friction between me and the table as I was being pulled. So as always, there's going to be weight, and then there's going to be a normal force from the table pushing up against me, and then I got pulled to the right, or more correctly, you could call that a tension force. And then opposing that motion was the kinetic friction. And the F net is not equal to 0 since I was moving. So technically this tension force is going to be way bigger than this kinetic to show that I was being pulled. So therefore the total F net is greater than, and points to the right to show that I was moving.
For our fourth example, we're going to create another scenario in which F net is equal to 0. So in this scenario, in the middle, Jess was getting pulled on in 2 directions with an equal amount of force. So we have a couple forces working here. The first one is going to be her weight force, mass times gravity. The second one is going to be the normal force going up just as before of the ground pushing up on her. And then we have 2 equal tension forces going to the left and the right. So on a coordinate system, this is going to have one force going down the mg, one force going up, with a net force, which will equal 0 movement in the y direction. And then we'll have a force coming this way, with the tension pulling to the left, tension going this way, with the tension pulling to the right. So these two will also equal 0 travel in the x direction. So therefore, F net is equal to 0.